Okay, so our experiment of today is increase of fluorescent lamp and power factor. And these are the objective involved of this experiment. So here is what we are going to learn the circuit wiring and operating principle of what the fluorescent lamps. And the two what verify the principle that capacitor connected in parallel to the circuit can increase the power factor. Okay, then this is the experimental equipment here. And EMT01 control panel, EMT03 three-phase switch, EMT04 analog meter 1, EMT07 analog meter 3, EMT010 fluorescent lamp, EMTS10 capacitor model, and you have a conduction wires also here. So let's see the experimental principle. The fluorescent lamps are comprised of tubes, ballast, and starter, as shown in figure 4 to 1. So this is it. So this is the tube. You have this is the tube ballast and the starter also here. As a switch over here as a starter. The glass tube is coated. So now the glass tube is what is coated with phosphor on the inside. And there is a set of filament on each end of the tube. So we have a set of filament. So this is the set of filament on each end of what of the tube. So this is the one filament here. This is the one filament here. Also here. When the AC power supply is applied, the filament emits and absorb electrons alternately. So it's going to emit and absorb electrons alternately. That's the alternate carrier. The length and diameter of the tube varies in proportional to the power. The ballast, an iron core coil. So the ballast is a coil, a form of coil, serves to light the lamp when the lamp is switched on and lower the voltage of the terminal afterward. So this is the function of the ballast. It serves to light the lamp when the lamp is switched on and when you lower the voltage of the terminal afterwards. In the ballast, there is a small glass bulb filled with neon gas and a paper capacitor. The bimetal electrode, one of the two electrodes of the glass bulb, is made up of sheet metal of two different expansion coefficients on the inside and outside. When heated, the sheet metal tilts and touches fixed rod electrodes, which is called the fixed contact pad, forming a closed circuit. The small capacity paper capacitor connected in parallel to the two electrodes of the small glass bulb serves to avoid the sparks igniting contact pad. So that's the function of what? The paper capacitor connected in parallel to the two electrodes of the small glass bulb serve to avoid the sparks igniting contact pad when the latter breaks contact with the sheet metal and eliminate the radio interference caused by the spark discharge. So that's the function of the paper capacitor. So supply 220 AC power to the fluorescent lamp. Then all the voltage is between the two poles of the starter. So the glow discharge is created by the ionization of the neon gas. At this time, filament, starter, and ballast form a loop. So when the voltage is what is applied to the circuit, the filament, starter, and ballast form what a loop. So a lot of electronics are transmitted by the filament. So a lot of electronics are transmitted by what the filament at the each end, the end of what of the tube. There is an electric contact in the starter which stops the discharge. The sheet, the sheet metal is cooling to recover, which causes the filament is turning hot and the circuit is break down. In that case, there comes a very high self-inductive EMF on the two ends of the ballast. So let's see. So now we know the ballast is there. It's a coil. So therefore it's going to generate what? Self-inductive. That's the self-inductive or EMF. That's the voltage. It's going to generate what? In on what? Voltage. Which is in series of the power voltage on the both end of the lamp. Therefore, the lamp is punched upwardly and discharged to emit UV. The UV radiates to the phosphor on the tube to make the ray like sunshine. During the working time of the tube, there is a high pressure drop on the ballast. So it will be going to be a high pressure drop on the ballast when the tube is working. The voltage on the ends of the tube is less than the half of the power. So the voltage on the ends of the tube is what? Less than half of the power. So that makes the starter to stop to discharge and breaking off contact. So now the shunt capacitor. So now we connected the shunt capacitor there. That's the capacitor module where we connected the shunt capacitor. So the shunt capacitor can improve the power factor of the fluorescent lamp. When the tube is working, the tube is a resistor type load, which is in series with the ballast, because the higher inductance of the ballast, the power factor of the tube is what? Lower. So when the inductor is higher, the power factor becomes what? Lower. So a capacitor is usually parallel on the side of the power to improve the power factor. So we are going to use the shunt capacitor, which connected in parallel to improve the power factor. So when the inductance it become higher, then we use the capacitor to bring it down. So that's why we are going to use the shunt capacitor to improve the power factor of the fluorescent lamp, because the balance is going to generate self-induced EMF. So when we use the capacitor, it's going to store some of the charges of the self-induced EMF of the balance, and it's going to bring the power factor up. So now, let's go to the wiring diagram. So this is the wiring diagram here. So this wiring diagram is the same as the measurement of power factor. So it's the same connection, but we didn't include the. So when you see that the wiring diagram is supposed to be ammeter is supposed to be there, and the power factor is supposed to be there, and voltmeter is supposed to be there. But because of this, they didn't add to it, so it's the same as what we did over here. So what is new here is the capacitor band, or the capacitor model. So let's move to the experiments. Let's see the connection. So now let's introduce the model, the equipment that we're going to use. Okay, so we have a control panel here. This is the control panel. We have a three-phase switch. This is the three-phase switch. Anode meter 1. This is the anode meter 1. Anode meter 3 is anode meter 3. The fluorescent lamp. We have the fluorescent lamp over here. The capacitor model is also here. And the connection wires. So let's start the connection. So we start from the live wire. So the live wire we say, so I pick it from here. It's a single phase, so I take one phase over here. Let me we input it here, then we add it at this. So the link is here, so I can put it, you can add it from here or add it from here, so they have the same link. So now from there to what? From the switch you go to the ammeter. So there's the ammeter. Put it here. As I said, the ammeter is always in series, so all live wire that is passing through the ammeter. So we input live wire, we output the live wire. Neutral is in parallel with the circuit. So live and neutral, that is entered the meter. Then I will tap it from here to the power meter. So that's it. So from the voltage side of power meter, you have a current side of power meter. So I will do some multiplication, so I'll multiply by what? The current, so I'll get it. So that's why I'll tap from here to this side. So here serves as well the output of the power meter. So we take the output of the power meter here. So from there to the power factor meter. So the connection. So from here to this side. From here, multiply it. Then take it from here. Then we send it to the capacitor module. So I said this one is a removable model, so we can remove it and bring it here. So let's remove that. We can remove it. So to pass through, from here. So this is the capacitor module. So take it from here. Then we send it to the fluorescent lamp, which is this. The fluorescent lamp. Okay, so now we are done with the live connection. So let's go to the neutral connection. So the neutral connection is also pick from the neutral sources. This is from there to the voltmeter. Then from the voltmeter, we tap from the voltmeter to the wattmeter. Then the wattmeter, we tap it from here to the power factor meter. So when the power factor meter, we tap it to the capacitor module. Then we tap from the capacitor module to the load with the fluorescent lamp. Then we check our continuity. So we are done. So we are checking our continuity to see if it is everything is working before we proceed to power it. We are checking the red one, so we put one at the red, then we check. Also the red one, the red wire, that's going to be the black one will not be. So the red wire, that's going to be. So we are done. We are coming to power it. See if the capacitor connected in power can improve the power factor. So that's what we are going to do. So when we power it, then what we started on the capacitor one by one after that to see if it's going to improve the power factor. So first, we turn on the key. There, come on. So now we are energized. So let's turn the lamp. Okay, so now, so this is what we have it here. So we are concentrating on the power factor, the power factor meter. So this is what we have it here. So let's see where it is.
So that is 0.98. So now let's introduce 1 microfarad capacitor and let's see. Let's introduce 1 microfarad capacitor. We'll bring 1 microfarad capacitor on. Then let's observe the changes. So initially it was exactly the 8. Now it will shift small. So now you see that it was improving. After we on the 1 microfarad capacitor, it will rise small. So now let's add the 2.2 microfarad capacitor to make it what? 3.2 microfarad capacitor. Let's see. So they are in parallel. So the parallel of a capacitor, that means what? Is we are adding, we are increasing the capacitance. So let's add. So we are adding 2.2 microfarad capacitor. So we have added. So we are getting what? 3.2 microfarad capacitor. So let's see the change. So you see the power factor have moved towards 0. It was 0.98. Now it has moved towards 0.99. So it's improving. So when you have so we can conclude it from our experiment. When capacitors are connected in parallel, it can increase what? The power factor, or can improve the power factor. So from the experiment, we can conclude that yes, it has been done. We are able to achieve what? Our objective.
Experimental summary. Through these experiments, we have learned the operating principle of the fluorescent lamp and understand the principle that capacitor connected in parallel to the circuit can increase the power factor. When the fluorescent lamp is switched on, the lamp serves as what? As a suitable resistance load. When it is connected in parallel to the ballast, because the inductance of the ballast is larger, the power factor of the fluorescent lamp is small. As a result, a capacitor C is often connected in parallel to the power supply to improve the power factor. We can also learn to use the 3-meter method to measure the power factor. Okay, so this is a summary of our experiment.